Good morning, everyone. I am Vinita, working as Associate Professor in the Department of Electrical and Electronics Engineering, RMD Engineering College. So, today I am going to discuss about a problem in symmetrical fault analysis in power system analysis. Let us see the problem. Generator G1 and G2 are identical and rated as 11 kV 30 MVA, have a transient reactance of 0.3 per unit at 1 MVA base. The transformers T1 and T2 are also identical and are rated 11 by 66 kV 10 MVA and have a reactance of 0.075 per unit to their own MVA base. Then the line is 60 kilometers long. Each conductor has a reactance of 0.92 ohms per kilometer. The three-phase fault is assumed at point F, which is 25 kilometers from the generator 1. Find the short circuit current. So here in this problem, two generators are connected and both the generators are nothing but identical generators and both are rated as 11 kV 30 MVA and its reactance is 0.3 per unit. So similarly, two identical transformers and both are rated as 11 by 66 kV and 10 MVA and its reactance is 0.075. So the transmission line is 60 kilometer long and its reactance is 0.92 ohms per kilometer. And here the fault has been assumed at point F, which is 25 kilometers from the generator. So this point is nothing but a faulty point. This is 25 kilometers from generator 1. And here for this problem, we have to calculate the value of the short circuit current. So for this first, we can draw the single line diagram and then we have to mark all the values above each and every component. Here you can draw generator G1, transformer T1, T2, generator G2. And in problem it is given the fault has been occurred 25 kilometers from generator G1. Since it is 60 kilometer from generator till this point it is 25 kilometer. From this 25 kilometer it is 35 kilometers. So 35 plus 25 is 60 kilometers. Okay, so now, to calculate the fault current, again we need to calculate the per unit reactance of each and every component in the circuit. So for this first we need to take the base MVA. So here the base MVA for generator 1 is 30 MVA. So this value we can assume as constant for the entire problem. And similarly, we have to divide this problem into various sections depends upon the connection of the transformer. Here two transformers are there. So we can divide this into three sections from generator G1 till this transformer T1 one section. From this transformer secondary to second transformer primary and then transformer T2 till generator T2 secondary to generator it is third section. So for this first we have to calculate the new kVB for each and every section. So if you take section 1, it is 11 kV. So why? Because the ratings of the generator 1 are chosen as base values. So if you apply the formula and if you calculate the value of new kVB, you will be getting only 11 kV. Okay. Then coming to the second section, this transmission line which is connected to the high tension side of the transformer T1. So that we can apply the formula KVB on HT side of transformer T1. So what is the formula? KVB on LT side of transformer T1 into HT voltage rating divided by LT voltage rating. What is this LT side of transformer T1? It is nothing but the new kV we have calculated for the first section. That is the new KVB of the section 1. That is LT side of transformer T1. It is 11 kV. 11 into HT voltage rating divided by LT voltage rating of this transformer. It is nothing but 66 divided by 11. So this 11 and 11 get cancelled and so the answer is 66 kV. Now coming to the third section, we need to calculate the kVB new. So what formula we can apply? Here this generator which is connected to LT side of transformer T2. So now this entire section gets over. Second section, this section we have to calculate. So this section is transformer primary. That is, sorry, transformer secondary low voltage side. So if you take the low tension or low voltage side, the formulas KVB on HT side of transformer T2 into LT rating divided by HT rating. So what is LT by HT? It is 11 bar 66 into what is KVB on HT side of transformer T2? Just now we have calculated it is 66 kV. So substitute here 66 divided by 66 get cancelled. So the answer is 11 kV. So for the section 3, the new KVB that is equal to 11 kV. Now we have calculated KVB new for all the sections. After calculating all the KVBs, we need to calculate per unit reactance for each and every component in the circuit. So for the first one is generator. So what's the formula to calculate per unit reactance of generator? Z per unit new is equal to Z per unit old into KVB old by KVB new the whole square into MVAB new divided by MVAB old. So if you take generator 1, Z per unit old. So it is Z per unit old is J.3. Substitute here, it is J.3. What is old by new? It is nothing but old values given 11 kV. What is new? It is also 11. So 11 by 11 into MVAB new by MVAB old. MVAB old is 30 and MVAB new we have chosen as 30. So 30 divided by 30. It is nothing but so this get cancelled and this get cancelled. So the answer is J.3 per unit. Similarly, for transformer 1, we have to calculate Z per unit new. Same formula we need to apply and we have to substitute the old values, new values, and so that transformer 1 per unit reactance is nothing but J.225 per unit. And transmission line. Since we are dividing the transmission line into two sections, we have to calculate the per unit reactance separately. So for 25 kilometer line. So for this 25 kilometer, coming under section 2, we have to calculate. So here the values given in ohms per kilometer, we have to use another formula to calculate Z per unit. So what's the formula? It is nothing but actual value divided by base value. Z actual is given in the problem and base value formula is nothing but KVB, KVB the whole square divided by MVAB new. So apply Z actual is J.92, KVB new is nothing but 66, and this MVAB new that comes in the numerator, so it is nothing but 30. So here the distance is given so that we have to multiply the entire value with 25 kilometers so that we will be getting the answers for J.158484 per unit. Similarly, for 35 kilometer length of the transmission line, we have to calculate Z per unit. It is again the same formula. If the value of the reactance is given in ohms, we need to use Z per unit mu is equal to Z actual divided by Z base. So this is Z actual divided by base value that is equal to KVB the whole square divided by MVAB. So this MVAB that comes into the numerator. So substitute the value J.92 into, you can substitute the value for KVB and MVAB. Then here the distance is nothing but 35 kilometer. So if you calculate, you'll be getting the answer is J.2218 per unit. Now next transformer T2, the same procedure we need to use to calculate per unit reactance of transformer 2 as well as generator 2. Okay, so after calculating all the values, we have to draw the reactance diagram. So first generator G1, then transformer T1, transmission line 1, transmission line 2, that is, this is the reactance till 25 kilometers. This is the reactance for 35 kilometers, then transformer T2, generator G2. So where the fault has been occurred at 25 kilometers from the generator G1. So this point that will be marked as the faulty point. Now we have to calculate the fault current. In order to calculate the fault current, we have to draw the Thevenin's equivalent circuit. So this is the equivalent circuit I have drawn. Here generator and its reactance, all the reactances are specified, and here as per Thevenin's theorem, at this faulty point the voltage is represented. and the voltage VTH that is equal to 1 angle 0 degrees. And in order to find the value of ZTH, we need to short circuit. If we have the voltage sources, then it should be short circuited. If we have the current sources, it should be open circuited. There is no current sources in the circuit, only we have two voltage sources. So we can short circuit these two voltage sources. So if you short circuit these two voltage sources, we will be getting the equivalent circuit like this. Okay. So at this faulty point, we can mark the value of ZTH. This is ZTH. Now we have to calculate the value of ZTH. So how to calculate? So in the left hand side, three impedances are connected in series, and the right hand side, three impedances are cconnected in series. You can add the impedances in the left hand side, right hand side. So in the left hand side, it is given as ZS1. It is J.6834. Similarly, if you add these three series impedances, you will be getting 0.7468. So if you redraw the diagram, left hand side impedance, right hand side impedance. Since these two are connected in parallel, we can redraw, that is, we can take this as Z parallel is equal to Z1 into Z2 divided by Z1 plus Z2, so that this is the equivalent impedance. So ZTH is equal to J.3568 per unit. So after calculating the value of ZTH, what is the next step? We have to draw the Thevenin equivalent circuit. So how to draw Thevenin equivalent circuit? VTH in series with ZTH. So what is VTH value? 1 angle 0 degrees. And ZTH, just now we have calculated, we can substitute. So at the end of the terminal, fault has been occurred. It is represented here. Now we have to calculate the fault current. So in order to find the fault current, we have to short circuit the faulty terminals. So the fault current IF that will be flowing through the circuit. So we can calculate the fault current. What is the formula? IF is equal to VTH divided by ZTH. So VTH is nothing but 1 angle 0 degrees divided by ZTH is equal to J.3568. So 1 divided by 0.3568 is 2.8023. If you take this numerator from the, if you take J from the numerator to the, denominator to the numerator, it becomes minus J. So J is equal to 90 degrees. So the answer is 2.8023 angle of minus 90 degrees per unit. Now we have to calculate the base current at the, that is, we have to calculate the fault current at the faulty point. So for this, so now we have calculated the fault current in per unit. So if you want to calculate the fault current in its actual unit, we have to multiply the fault current, that is per unit value, with the base value. So what is the formula to calculate base current? MVAB divided by root 3 into KVB. So what is MVAB? MVAB mu is common. So it is 30 into 10 power 6 divided by root 3 into what is KVB? So where the fault has been occurred. So here the fault has been occurred at this terminus. So its voltage is nothing but 66 kV. That voltage here we need to substitute root 3 into 66 into, here it is 10, they have taken as 10 power 6 and it is 10 power 3. So that we will be getting the common answer, because the power is in MVA, voltage is in kV. So that we need to convert this MVA into VA. So we have to multiply with 10 power 6. And if you want to convert this kV into V, you can multiply with 10 power 3. Or otherwise, you can convert this MVA into kV. Then you can cancel this K and K, so that also you will be getting the same answer. So the total fault current, the actual value of fault current, that is equal to per unit value into base value, that is 735.41 angle of minus 90 degrees amps. So this is the value of fault current IF. So by applying Thevenin's theorem here, the fault current that will be calculated. So if it is in per unit, we can take the ratio of VTH by ZTH. Or if you want to calculate the fault current in its actual unit, then we have to calculate the per unit value of fault current with the base value, so that we can we'll get the result in terms of amperes. Thank you.